everyone, welcome. This is part 4 of plane. So, you haven't watched part 1, part 2, part 3. So, go through that. So, what we are doing in planes is we have been solving the problems based on angle between the planes, right? So, the previous class, we have solved first 5 problems based on angle between the planes, and we have seen 4 important notes. So, we have been doing some problems based on this. The previous class, we have solved 5 problems, right? Overall, we're going to do 11 problems in this subtopic. So in this class, we will be finishing the remaining problems. That is, we will be doing problem 6, 7, 8, 9, 10, 11, right? So we'll be doing another 6 more problems, right? Another 6 more problems. So we will start, right? So all the problems in this class are very important. All are very, very easy, provided you understand the concept, right? So we'll start the first problem. So again, it's a very, very interesting problem. Solution. So we have find whether the 2 points lie on the same side or opposite side of the plane, right? So they have given the plane. So they have given the plane. So they have given the plane 2x minus 2y plus z minus 6 is equal to 0, right? So we need to say whether these 2 points lie on the same side or opposite side, right? So we already know. Just substitute the point here. Substitute the point here. If both are of same sign means it is on the same side. If both the points are of opposite sign means it is on opposite side, right? Now substitute the point. Substitute the point 2 comma 0 comma 1 in this plane, right? So in 1, so we will be having uh, x is 2, y is 0, z is 1. This will get vanished. So 2 plus 1 is 3. It is minus 3, which is negative, right? It's negative. And similarly, now you put, now you substitute the point. Now you substitute the point 3 comma minus 3 comma 4 in 1, right? So in 1, you will have 3 minus 2 into minus 3 plus z minus 6. So this will be 3 plus 6 plus 4 minus 6. So these two will get cancelled. So we have this to be equal to 7, right? So 3 minus 2 into minus 3 plus 4 minus 6 is. Now we can see it is positive, right? Both are of opposite sign, right? So both are of opposite sign. Both are of opposite sign, right? So therefore, the 2 points lie on the opposite side of the plane x minus 2y plus z is equal to 6, right? So this problem is based on note 2, right? So note 2 is 2 points x1 y1 z1 x2 y2 z2 lie on the same side or opposite side of the plane, according as if these two are of same sign means same side, if these two are of opposite sign means they are opposite side, right? We'll move on to 7th problem. Find the perpendicular distance between the parallel plane 2x minus 3y minus 6z minus 21 is equal to 0 and 2x minus 3y minus 6z plus 14 is equal to 0. Obviously, these two are parallel, right? Why? Because only thing is here we have minus 21, here we have plus 1 plus 4. Okay, now we'll move on to problem number 7. To find the perpendicular distance between the two parallel plane. They have given two parallel plane. So we need to find the perpendicular distance between the two parallel plane, right? So we already know. So we already seen a note 4 the previous class. We know how to find the perpendicular distance between the two parallel plane. So you need to find the perpendicular distance from origin to the first plane. That is called that as D1, and you find the perpendicular distance from origin to the second plane, call that as D2. The algebraic difference of these two perpendicular distance is the distance between the two parallel plane, right? So we're going to make use of that note here. To find the perpendicular distance between the parallel plane, right? So we have the first plane 3x. So we have first plane 2x minus 3y 2x minus 3y minus 6z minus 21 is equal to 0. So this is the first plane, right? So this is the first plane. And we have other plane, parallel plane, which is 2x minus 3y minus 6z plus 14 is equal to 0, right? We need to find this perpendicular distance between them, right? We need to find the perpendicular distance between the two parallel planes. So for that, what you have to do? So you find the perpendicular distance from origin to the first plane, call that as d1, and you find the perpendicular distance from origin to the second plane, call that as d2, right? Call that as d2. The algebraic difference of d1 and d2, yes, algebraic difference of d1 and d2 is the required uh, perpendicular distance between the two parallel planes, right? So let O be the origin, right? So let us take let O 0 comma 0 comma 0 be the origin, right? So by note 4 we know that so just go through note 4 that we discussed in the previous class. The algebraic difference of these two perpendicular distance, that is, first find the length of the perpendicular distance of each plane from the origin. We know that first find the length of the perpendicular distance um, from origin to the given planes, right? To the given planes, the algebraic difference of these two distance is the distance between two parallel planes, right? Is the distance between two parallel planes, right? So first you find d1. Now first you find d1. So d1 is the perpendicular distance from origin, right? That is from 0 comma 0 comma 0 to the plane 2x minus 3y minus 6z minus 21 is equal to 0. So what is perpendicular distance? So it is given by, I'm taking positive, right? I'm taking positive. This will be ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This is the perpendicular distance from point to the plane. This will be equal to, the plane is 2x1 minus 3y1 minus 6z1 minus 21 divided by root of a square plus b square plus c square. So you substitute the point 0 comma 0 comma 0. This is our x1 y1 z1. So this will be, so this 0 0 0. We will be having minus 21 divided by 7, which is minus 3, right? So you can see how the diagram will be like, right? The plane will be at the top, origin will be at the below. So that only we are having negative 3 units from origin to the first plane. Now similarly, you find this is a rough diagram. Now we will draw the exact diagram after this, right? Now what is d2? Now d2 is the perpendicular distance. d2 is the perpendicular distance from 0 comma 0 comma 0 to the second plane 2x minus 3y minus 6z plus 14 is equal to 0. Therefore, this is 2x1 minus 3y1 minus 6z1 plus 14 divided by root of a square plus b square plus c square. Now substitute the point 0 comma 0 comma 0. So this will be 14 divided by 7, which is 2, right? And we know that distance between two parallel plane is nothing but the algebraic difference, which is d2 minus d1. So d2 is 2 minus of minus 3. Therefore, 5 units is the distance, right? So 5 units is the distance between the two parallel planes. That is, here we have negative 3 because how this plane will be like. So this plane will be like, so we have, this is the first plane. So we have 2x minus 3y minus 6z minus 21 is equal to 0. So origin will be here. So that's why only we are having negative 3 units as the distance, right? We have plus 3 means you will take this distance as plus 3, right? Both are equivalent distance only. One is above, one is below. Now similarly, the second plane has a distance of what? It's a distance of what? You can see D2. The perpendicular distance from origin to the second plane is 2. That means um, this will be 2, right? This will be 2. This will be 2, right? This is 2. 2, and this plane is 2x minus 3y minus 6z plus 14 is equal to 0. What is the distance between both the plane? It is nothing but 5, right? So here we have 2, here we have 3. Overall, the distance is 5. So therefore, this is the exact diagram for the given plane, right? We'll move on to 8th problem. 8th and the 9th problem are very important problem, right? So we'll do 8th problem. We'll start 8th problem. Very important problem, right? Very important problem, interesting problem also. So find the equation of plane. That plane should pass through 1 comma 0 comma minus 2 and perpendicular to each of the plane 2x plus y minus z minus 2 is equal to 0 and x minus y minus z minus 3 is equal to 0. Right? Very interesting problem. So we'll start solution. To find an equation of plane passing through the point 1 comma 0 comma minus 2. First, that plane has to pass through the point 1 comma 0 comma minus 2. Right? So what is an equation of plane passing through the point? Very important, right? I have already given the note in the very first class. We have talked about equation of plane passing through a point and perpendicular to given line. If the line is not given, you take that line to be the normal. I have already said, right? Just go through part 1. So we know that equation of plane, we know that equation of plane uh, passing through 1 comma 0 comma minus 2 or okay, before that we will I'll general formula. So passing through x1 y1 z1 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the required equation where a comma b comma c are the normals are the direction ratio of the normals, right? Now it is passing through the point 1 comma 0 comma minus 2. So it is passing through. So it is through the point passing through the point 1 comma 0 comma minus 2. So the required equation of plane is a into x minus 1 plus b into y minus 0 plus c into z plus 2 is equal to 0, right? This is the required equation. Call this as 1, right? But we don't know what is ABC, right? We don't know ABC where A comma B comma C are the direction ratio of the normal, right? This is what we need to find, but we don't know ABC, right? How to find ABC? We will do this. Now, find the equation of plane passing through the point, right? So from this data, that is find the equation of plane passing through 1 comma 0 comma minus 2. We have got equation number 1. Now, this plane is perpendicular to this plane as well as this plane, right? Now, 1 is perpendicular to, that is this plane is perpendicular to 2x plus y minus z minus 2 is equal to 0, right? So what is the direction ratio of this plane? What is the direction ratio of the normal for this plane, right? Direction ratio of normal for this plane is 2 comma 1 comma minus 1, right? Ax plus by plus cz plus t is equal to 0. That is the general equation of plane. A comma b comma c is the direction ratio of the normal. So that means we know direction ratio of the normal to the first plane, and also we know direction ratio of the normal to this plane also. And we know these two are perpendicular, right? So that is 1 and 2 are perpendicular. 1 and 2 are perpendicular. 1 and 2 are perpendicular. That means two planes are perpendicular, right? That means what? That means what? That their normals are perpendicular, right? That means A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Now, ABC is the direction ratio of the normal. Here 2, 1, minus 1 is the direction ratio of the normal, right? That is, here A1, B1, C1 is A, B, C, and A2, B2, C2 is 2, 1, minus 1, and these two are perpendicular. This implies A1, A2. So 2 into A, 2A plus B minus C is equal to 0. Call this as, okay, call this as star, right? Call this as star. Now, similarly, you can see find an equation of plane passing through the point 1, 0, minus 2. So this is the required equation. This required equation is perpendicular to this plane as well as perpendicular to this plane also, right? So first we have used first now one is perpendicular to the first plane. From this we have got 2A plus B minus C is equal to 0. Similarly, one is also perpendicular to this plane also, right? So similarly, one is also perpendicular to x minus y minus z minus 3 is equal to 0. So what is the direction ratio of normal to this plane, for this plane? What is the direction ratio of normal? It is 1, minus 1, minus 1, right? So we have, so since they are perpendicular, since both the planes are perpendicular, okay, let us call this as 3, right? So since 1 and 3 are perpendicular, both are planes, right? Since 1 and 3 are perpendicular, this implies their normals are perpendicular. Two planes are perpendicular if normals are perpendicular, right? Their normals are perpendicular, right? That means normal for first plane, right? So actually I don't want to confuse you, right? Very simple. So their normals are perpendicular. So 1, minus 1, minus 1 is the normal for this plane, and A, B, C is the normal for the first plane. That means we will be having A, B, C is the normal for equation number 1, and 1, minus 1, minus 1 is the normal for equation number 2. So they are perpendicular. This implies A minus B minus C is equal to 0 because 1 is perpendicular to 3, right? Because this is a required equation. This required equation is perpendicular to this plane as well as this plane. Very simple, right? So this as ABC is the direction ratio of this plane, right? So this plane is perpendicular to this plane. That means this plane has direction ratio 2, 1, minus 1. So this plane has direction ratio of the normal, right? So 2, 1, minus 1. And this has direction ratio A, B, C. And both are perpendicular. That means what? 2 into A plus 1 into this one we have, right? 1 into B plus C is equal to 0. Similarly, this equation is perpendicular to this also. So what is the direction ratio of the normal to this plane? 1, minus 1, minus 1. So 1, minus 1, minus 1 is the direction ratio of the normal. And we know A, B, C is the direction ratio of the normal to this plane, required plane, and these two are perpendicular. So A1, A2 plus B1, B2 plus C1, C2 is 0. So you will have the second equation, right? So you will have this equation. So all this as double star. So star and double star, you will have ABC. That's it, right? And then substitute back in equation number 1. This is the required equation, right? This is the required equation. This is the required equation, right? Okay. Now solving star and double star. So solving star and double star. So I'm going to do by cross multiplication method. So we need to solve 2a plus b minus c is equal to 0. A minus b minus c is equal to 0, right? So I'm going to solve by cross multiplication method. Solve by cross multiplication method. So these are 10th standard level, right? So you just have to do a divided by b divided by c divided by. So you just take the middle term, right? You just take the middle term coefficient. So start from the middle term. So 1 minus 1 2 1. So 1 minus 1 2 1, right? So start from the middle term 1 minus 1. You just take the coefficients 1 minus 1 2 1. Now go for second equation. So minus 1 1 minus 1, right? 1 minus 1. This is A, this is B, this is C. Now cross multiply this. So 1 into minus 1 is minus 1. In between you have minus. So minus 1 is plus 1. And here 1 minus 1 into minus, this is minus 1. In between you have minus. Here we will have minus 2. So 2 into minus 1 is minus 2. In between you have minus. So 1 into 1 is 1. So let us say this is equal to some k. Right? K is a constant. Means A is equal to minus 2. Let's write one more step here. So we have A by minus 2 is equal to B by 1, right? Because minus 1 plus 2. C by minus 3 is equal to K. This implies A is equal to minus 2K. A is equal to minus 2K, B is equal to K, and C is equal to minus 3K, right? This is the required value of ABC. So substitute in equation number 1. Substitute in equation number 1. So the required equation of plane is the required equation of plane is A into x minus 0, A into x minus 1, B into y minus 0 plus C into z plus 2 is equal to 0. So A is minus 2k into x minus 1, B is k into y, C is minus 3k into z plus 2 is equal to 0. I ended k outside, right? K outside. This k is not equal to 0, right? It's a proportionality constant. So the k outside will be having minus 2 into x minus 1 plus y minus 3 into z plus 2 is equal to 0. This k is not equal to 0. This implies this term has to be 0. Multiply this minus inside. So minus 2x plus 2 plus y minus 3z minus 6 is equal to 0. So minus 2x plus y minus 3z minus 2x plus y minus 3z. 2 minus 6 is minus 4 is equal to 0. Or 2x minus y plus 3z plus 4 is equal to 0 is the required equation of plane. Right? Very, very important problem. So we need to find an equation of plane passing through the point 1, 0, minus 2. That is given by this, right? But we don't know ABC. To find ABC, now this ABC is the direction ratio of the normal of the required plane. Now we know this plane and this plane are perpendicular. Two planes are perpendicular if their normals are perpendicular. Now this plane has a normal 2, 1, minus 1. So we know this plane has normal a, b, c. This plane has normal 2, 1, minus 1. So since they are perpendicular, what is the condition for perpendicular of their normals? A1, A2 plus B1, B2 plus C1, C2 is 0. So we have 2A plus B minus C is equal to 0. Right? And similarly, this plane and this plane are perpendicular. This plane has direction ratio a, b, c. And this plane has direction ratio 1, minus 1, minus 1. So this plane has if I say direction ratio means direction ratio of the normals, right? So this plane has direction ratio of the normal is a, b, c. This plane has direction ratio of the normal 1, minus 1, minus 1. So this is a, b, c. This is 1, minus 1, minus 1. They are perpendicular. That means a1, a2 plus b1, b2 plus c1, c2 is 0. So we have a minus b minus c is equal to 0. So we have 2a plus b minus c is equal to 0. A minus b minus c is equal to 0. So solving these two will give you the value of ABC. So we will have ABC in terms of k. Substitute back here. K, take that k outside. And since k is not equal to 0, so you are multiplying two terms. You are getting 0 as an answer. This k is not equal to 0. That means this entire term has to be equal to 0. Now just multiply this, simplify this, you will have 2x minus y plus 3z plus 4 is the required equation of plane, right? So very important problem in exam point of view. We'll move on to ninth problem. This plane has direction ratio a comma b comma c, and this plane has direction ratio 1 comma minus 1 comma minus 1. So this plane has a comma, sorry, if I say direction ratio means direction ratio of the normals, right? So this plane has direction ratio of the normal is a comma b comma c. This plane has direction ratio of the normal 1 comma minus 1 comma minus 1. So this is a comma b comma c. This is 1 comma minus 1 comma minus 1. They are perpendicular. That means a1 a2 plus b1 b2 plus c1 c2 is 0. So we have a minus b minus c is equal to 0. So we have 2a plus b minus c is equal to 0. A minus b minus c is equal to 0. So solving these two will give you the value of abc. So we will have ABC in terms of k, substitute back here, k, take that k outside, and since k is not equal to 0, so we are multiplying two terms, we are getting 0 as an answer. So this k is not equal to 0, that means this entire term has to be equal to 0. Now just multiply this, simplify this, you will have 2x minus y plus 3z plus 4 is the required equation of plane, right? So very important problem in exam point of view. We'll move on to ninth problem. Similar to eighth problem, find an equation of plane passing through the points 1 comma minus 2 comma 2 minus 3 comma 1 comma 2 and perpendicular to the plane x plus 2y minus 3z is equal to 5. In the previous problem, they have given passing through one point and perpendicular to two planes. Here they have given passing through 2 points and perpendicular to one plane. And can you see the difference between problem 8 and problem 9? In problem 8, they have given, we need to find the equation of plane. That plane is passing through one point and that plane is perpendicular to two planes. Here they have given the data that the plane is passing through 2 points and perpendicular to this plane, right? Okay, no problem. We will do as same as previous problem. So we will consider only one point as of now, right? So equation of plane passing through equation of plane passing through 1 comma minus 2 comma 2 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, right? Let us take only one point, right? Okay. Now what is x1 y1 z1? So it is a into x minus 1 plus b into y plus 2 plus c into z minus 2 is equal to 0 is the required equation, right? Is the required equation of plane, but we don't know ABC. The previous problem, we have two planes that are perpendicular to this plane. So therefore, their corresponding normals are perpendicular. So we have used the condition that A1, A2 plus B1, B2 plus C1, C2 is equal to 0. We have got two equations in terms of ABC. We have solved that to find the value of ABC, right? Now, let us do the same, right? Now, this plane, let's call this as 1, right? Now, it is perpendicular. Now, okay. What is ABC? Before that, we'll denote ABC, where ABC are the direction ratio of the normal to the plane, right? Of the normal to the plane. Normal to the plane. Drawn from the origin, right? Okay. Let us call this as equation number 1. Now, this plane is passing through this plane is passing through as well as minus 3 comma 1 comma 2, and also this plane is perpendicular to the x plus 2y minus 3z minus 5, right? So we'll do this. This plane is perpendicular to x plus 2y minus 3z minus 5 is equal to 0. Implies what is the direction ratio of normal to this plane is 1 comma 2 comma minus 3, right? So these two are perpendicular, right? These two are perpendicular. Since they are perpendicular, these two places are perpendicular, the corresponding normals are perpendicular. That means the direction, we know direction ratio of both the normals. This implies a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So ABC is the normal of the first plane. 1, comma 2, comma minus 3 is the normal of the second plane. So since they are perpendicular, we have A. So I can see just have to multiply, right? So A comma B comma C, and we have 1 comma 2 comma minus 3. This is the direction ratio of the normal of the first plane A1 B1 C1, and this is the direction ratio of the normal to second plane. They are perpendicular. That means A1 A2 plus B1 B2 plus C1 C2 is 0. So we have A into 1 plus B into 2 plus C into minus 3 is equal to 0. So we have A plus 2B minus 3C is equal to 0. Call this as star. Now you can see this plane is also passing through the point minus 3 comma 1 comma 2. Previous problem they have given only one point and they have given two perpendicular planes, right? Now um the required plane, right? So required plane, the one is the required plane is passing through the point minus 3 comma 1 comma 2. That means this plane will satisfy this equation, right? So A into this point will satisfy this equation. So A into x minus 1, B into y plus 2 plus C into z minus 2 is equal to 0 is a required equation that is passing through minus 3 comma 1 comma 2. So we will have minus 3 minus 1, 1 plus 2 plus C into 2 minus 2 is equal to 0, right? So minus 3 comma 1 comma 2. So we have z minus 2. Okay. So this will be minus 4a plus 3b plus 0c is equal to 0. Yes or no? So why? Because this plane is perpendicular to this plane. So we are using the concept of direction ratio of the normals are perpendicular. And this plane is also passing through the point minus 3 comma 1 comma 2. That means we substitute this point minus 3 comma 1 comma 2 here. This will be satisfied, right? So we will call this as double star. That's it. Now solve star and double star. You can find the value of ABC, substitute back in equation number 1. That will be the required equation, right? So solving star and double star. Solving star and double star. So we have A plus 2B minus 3C is equal to 0, right? A plus 2B minus 3C is equal to 0. So double star is minus 4A plus 3B plus 0C is equal to 0, right? Just solve this. So A divided by B divided by C divided by. So we just start with this term. So 2 minus 3. So 2 minus 3, 1, 2, right? 2 minus 3, 1, 2. So 3, 0, 3, 0, minus 4, 3, right? Minus 4, 3. This is A, this is B, this is C. Now multiply this. So 2 into 0 is 0. In between you have minus. So 3 into minus 3 is minus 9. And here we have, this is 12 minus 0, right? 12 minus 0. And 3 minus 2 into minus 4 is minus 8. All this as equal to k. So we have A by 9 is equal to B by 12 is equal to C by 11, right? So 3 plus 8 is 11 is equal to k. This implies A is equal to 9k, B is equal to 12k, C is equal to 11k. So substitute in 1. The required equation of plane is required equation of plane is A into x minus 1 plus B into y plus 2 plus C into z minus 2 is equal to 0. So we have A to be equal to 9k into x minus 1 plus 12k into y plus 2 plus 11k into z minus 2 is equal to 0, right? 11k into z minus 2 is equal to 0. So just take this k outside. So we have 9 into x minus 1 plus 12 into y plus 2 plus 11 into z minus 2 is equal to 0, right? I think you're doing right. I think you're doing correct. A plus 2b minus 3c is equal to 0. Minus 4a plus 3b plus 0c is equal to 0. So 2 minus 3, 1, 2, 3, 0, minus 4, 3. So 0 minus of minus 9 plus 9, 12, 3 plus 8. So 3 plus 8 is 11. Yes. So this k is not equal to 0. This implies so 9x minus 9 So since k is not equal to 0, so this term has to be 0, right? So this term has to be 0 because you are multiplying two terms, you are getting 0 as an answer. This k is not equal to 0. That means this term has to be 0. So 9x minus 9 plus 12y plus 24 plus 11z minus 22 is equal to 0. So 9x plus 12y plus 11z, and so this will be 24 minus 2 is 2, minus 9 plus 2 is minus 7 is equal to 0 is the required equation. That's it. Right? In the previous problem, we have a plane passing through one point and perpendicular to two planes. Here, a plane is passing through 2 points and perpendicular to one plane. Right? So very simple, right? So you can do, this is one of the method, right? You can do in the other way also, right? You can do in other way also, many methods. This is one of the easiest method, right? So equation of, you just take only one point as of now. Equation of plane passing through the point 1 comma minus 2 comma 2 is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is 0. Substitute that point here. Now this required equation is passing through this point as well as perpendicular to this plane. So you have two constraint here. So you will have substitute those two data here. You will have two equation in terms of ABC. Solve that to get the value of ABC. We're getting A to be equal to 9k, B to be equal to 12k, C to be equal to 11k. So we substitute that, you will get the required answer, right? You can check it here, right? If you put if you put k is equal to 1 means we have A to be equal to 9, B to be equal to 12. Substitute here. So minus 4 to 9 is the minus 36. Plus 3 to 12 is plus 36. So that means minus 36 plus 36 will be equal to 0. It is satisfied. So therefore, these are correct, right? Substitute back here, you'll get the required equation of plane, right? So problem number 8 and 9 are very important. From this, you will have usually majority of questions, right? We need to find the equation of plane passing through perpendicular, passing through some point perpendicular to this. These are this kind of questions. Now move on to problem number 10 now. So problem 10 and 11 are similar problems. So we'll do the problem number 10 now. Find the equation of locus of a point B whose distance from the plane 3x minus 2y plus 3z plus 4 is equal to 0 is equal to distance from the point minus 1 comma 1 comma 2. Right? I think it's very easy problem, right? Question seems to be complicated, but these are very easy. So what is locus? Locus is a set of points that satisfy some equation, right? Let us take a point P. So this point P is x1 comma y1 comma z1, right? To find the equation of locus of a point P whose distance from the plane is equal to, okay. So we have, okay. We need to find all those x1 comma y1 comma z1, right? We need to find all those points such that the distance from that point to the plane, the distance from that point to the plane, 3x minus 2y plus 3z plus 4 is equal to 0, right? We need to find all those points such that the distance from plane to that point, this distance, right? This distance is equal to distance from the point. Let's say this point is minus 1 comma 1 comma 2, right? So we need to find all those points x1 comma y1 comma z1 such that the distance from that point to plane is same as that point to minus 1 comma 1 comma 2. So there can be many points, right? There can be many points x1 comma y1 comma z1 that satisfies this condition. What is the condition? That x1 y1 z1 should satisfy the distance from that point to plane is same as distance from that point to minus 1 comma 1 comma 2, right? Let us call this as P, right? Let us call this as D. That means P has to be equal to D, right? Okay. So we need to find all those points. So it is not possible to find all those x1, y1, z1, right? There are infinitely many x1, y1, z1 that can satisfy this condition. We need to find the locus of a point P. That is, there can be infinitely many points x1, y1, z1. But you tell me the equation that all those points will satisfy. That is called locus, right? When I say locus means there are infinitely many x1, y1, z1 that satisfies this condition. You cannot able to list out all those infinite values. But what you can do is you can say, here it is. This is the equation that all these points will satisfy. So they are asking the equation that all the point will satisfy. That is called locus, right? So locus is the equation that a set of point will satisfy, right? Locus is an equation that a set of points will satisfy some condition. Here the condition is the set of points will satisfy the condition that whatever point you take, the distance from that point to plane is same as distance from that point to the point minus 1 comma 1 comma 2. Right? I'll repeat. Locus. When I say locus means there can be infinitely many points that satisfy the condition that whatever point you take, the distance from that point to this point is same as distance from that point to plane. So there can be infinitely many points, but all those points will satisfy some equation. Right? All those points will satisfy some equation. That equation is called locus. Right? We need to find the all those x1, y1, z1. You need to find an equation that x1, y1, z1 satisfies, right? Remember, there can be infinitely many x1, y1, z1, right? There can be many infinitely x1, y1, z1, right? It is not possible to list out all those, but we will find a general equation that our x1, y1, z1 will satisfy. Don't think that there is only one point that will satisfy this condition. There can be infinitely many points. Even though there are infinitely many points, to tell the equation that these points will satisfy. That is what they are called locus. Okay. So let P be the perpendicular distance from x1, y1, z1 to the plane 6x minus 2y plus 3z plus 4 is equal to 0. So what is the distance? So P is equal to, what is the formula? Ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square, right? This is the perpendicular distance. So this will be equal to, the plane is 6x1 minus 2y1 plus 3z1 plus 4 divided by root of a square plus b square plus c square. So this turns out to be, so here our x1 comma y1 comma z1 will remain as it is, right? Because we don't know this point. So let us keep that as it is. Therefore, the P is 6x1 minus 2y1 plus 3z1 plus 4 divided by 7, right? So therefore, the distance P is given by this, right? Cause this as 1. Now, let, let D be the distance from the point x1, comma y1, comma z1 to the point minus 1 comma 1 comma 2. Very simple, right? What is that distance between 2 points? So d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this will be x1 plus 1 whole square, y1 minus 1 whole square, z1 minus 2 whole square, right? Both are same, right? Minus 1 minus x is same as x1 plus x2 minus x1. You just take this as x1 y1 z1. Take this as x2 y2 z2. So you'll get this equation, right? No problem. You can reverse distance between a to b is same as b to a, right? Okay. So this is the distance d. This d is given by root of x plus 1 whole square plus y1 plus 1 whole square plus z1 minus 2 whole square, right? Root of x1 plus 1 whole square, y1 minus 1 whole square, z1 minus 2 whole square. Now, according to the data, P has to be equal to D, right? Now according to the question, P has to be equal to D, yes or no? Because find an equation of locus of a point P whose distance from the plane is equal to distance from the point minus 1 comma 1 comma 2, right? According to the question, P is equal to D. That means what is P? So P is 6x1 minus 2y1 plus 3z1 plus 4 divided by 7 is same as root of x1 plus 1 whole square plus y1 minus 1 whole square plus z1 minus 2 whole square, right? This is the locus of a point. If you want, you can simplify, or else you can leave itself, right? All your x1, y1, z1 will satisfy this equation, right? So equation, that is a locus. Or you can square it. If you want to simplify to simpler manner, squaring on both sides. This will be 6x1 minus 2y1 plus 3z1 plus 4 whole square. So break 7 square is 49. Take it to that side. And if we square it, root will get cancelled. So we have 49 into x1 plus 1 whole square plus y1 minus 1 whole square z1 minus 2 whole square, right? If you want, you can simplify this to some more extent also, right? So we have a plus b plus c plus d whole square. So what you can do is you can expand, right? You just take this as a, take this as b. So a plus b whole square formula. If you don't know a plus b plus c plus d whole square, break this into two parts. So a plus b whole square is a square plus b square plus 2 times ab is equal to 49 into this will be a square plus b square plus 2ab. This will be a square plus b square minus 2ab, and this will be a square plus b square minus 2ab. Okay? Multiply this 49 inside. I think you can do this, right? Very simple. And then exam point of view, you can leave here itself, right? You can leave here itself. You don't want need simply. You just need an equation that your x1, y1, z1 should satisfy. You can say this is the equation your x1, y1, z1 will satisfy. That is all the points. There can be many x1, y1, z1, right? So for this point also, the distance between the plane is same as distance between the point. For this point also, distance between the plane is same as distance between the point. For this point also, distance between this is same as distance between this. So all your x1, y1, z1 will satisfy this equation. Right? If you want, if you have time means, what you can do is you can again expand a minus b whole square formula, a plus b whole square formula, and expand multiply 49 inside, multiply this inside, or you will have. So I'll write on the simplified equation. Overall, you're going to have, it will be 13x square, 13x1 square plus 45y1 square plus 40z1 square, 40z1 square plus 24x1y1 plus 24x1y1 minus 36x1z1 plus 12 times y1z1 plus 50x1. Very long equation. So 50x1 minus 82y1 minus 82y1 minus 220z1 minus 220z1 plus 278 is equal to 0 is the required locus of P, right? I think you can stop here itself in exam point of view. If you have time, you can expand, right? I think you can get it right. Here you will have 49x1 square, right? Here you will have 49x1 square. Here you will have 36x1 square, right? If you expand here, 36, here you will have 36x1 square. And here you will have 49x1 square. So bring this to that side. You will have 49 minus 36, 36x, 13x1 square, right? And similarly, here you will have 4y1 square, right? And here you will have 49y1 square, right? Here you will have 49y1 square. So bring this to that side and subtract. You will have 45y1 square, right? Similarly, you can do all those. You will be getting this as the required locus. So your x1, y, all your x1, y1, z1 will satisfy this equation, right? So whenever your x1, y1, z1 satisfies this equation, you can say the distance from that point to plane is same as distance from that point to the point minus 1 comma 1 comma 2, right? So again, very easy problem, right? If you understand the concept, these are very easy problem. I'll move on to 11th problem. Again, 11th problem is same as this. So find the locus of a point such that The sum of the squares of whose distance from the plane is 7, right? So we need to find all those point P, right? So we need to find the locus of a point P. So let that locus be x1, y1, z1. There can be many x1, y1, z1 that satisfy this condition. You don't need to list out all those x1, y1, z1. You tell me the equation that those x1, y1, z1 will satisfy. That is called locus, right? So P is x1, y1, z1. Find the locus of a point, okay, such that the sum of the squares of whose distance from the plane is 3. Okay. So that from this point, the distance between, okay, from this, we have three planes, right? We have three planes. We have three planes, right? We have three planes, x plus y plus z is equal to 0, x minus y is equal to 0, x plus y minus 2z is equal to 0, right? To find the locus of a point P such that sum of the squares of whose distance from the plane to that point. Okay. So let this be distance from this plane to that point, plane to that point, plane to that point, right? Let all this perpendicular distance, right? Just for understanding, I'm drawing this. Let all this be perpendicular distance. Okay. Now, let us call this as D1, call this as D2, call this as D3. Now we need to find all those point P such that d1 square plus d2 square plus this distance has to be equal to 7, right? Find the locus of a point P such that the sum of the squares of whose distance from the plane is 7. That is, we need to find all those x1, y1, z1 such that d1 square plus d2 square plus dt square. Okay, if you want, let us write p1, right? Because let this denote the perpendicular distance p1, p2, p3. Uh, okay. Okay. Now, so let P of x1, y1, z1 be the required, be the required point whose be the point whose locus is required, right? Okay. So let us take P1. So P1 is distance of P from the plane x plus y plus z is equal to 0, right? What is this distance? Is x1 plus y1 plus z1 divided by root of x1 square, okay, root of a square plus b1 square plus 1 square plus 1 square, right? So ax plus by plus cz plus d root of a square, okay. If you want, I can also write this in p point is x1, y1, z1, right? Distance of P x1, y1, z1 from distance of P from the plane from the plane x plus y plus z is equal to 0. So this we know the distance is ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. So the plane is x plus y plus z. That is a is 1, b is 1, c is 1, d is 0. So we have x1 x1 plus b plus c, right? So here xyz point is x1 y1 z1, right? Divided by root of a square plus b square plus c square. So this is x1 plus y1 plus z1 divided by root 3 is this distance, right? Similarly, P2 is equal to perpendicular distance, right? RR. Distance of P x1 y1 z1 from the plane x minus y is equal to 0, right? This is given by ax plus by plus cz plus d divided by root of a square plus b square plus c square. So here 1 into x minus y plus 0 z plus 0 divided by root of 1 square plus 1 square plus 0. So we will have x1 minus y1 divided by root 2, right? Because we're substituting x1, y1, z1 in this point. And similarly, you find P3. So P3 is distance of the point x1, y1, z1 from the plane. What is third plane? It is x plus y minus 2z is equal to 0. So this is given by x1 plus y1 minus 2z1 divided by root of a square plus b square plus c square. This is x1 plus y1, x1 plus y1 minus 2 times z1 divided by root 6, right? Now, according to the question, sum of the squares of distance has to be equal to 7. So according to question, right? So according to the question, according to the question, P1 square plus P2 square plus P3 square has to be equal to 7, right? Sum of squares of whose distance from the plane is 7. So just square it out. So we square it out. P1, we know P1, P2, P3. So we square it out. We will have 1 by 3 x1 plus y1 plus z1 whole square. And what is P2 square? 1 by 2 into x1 minus y1 whole square. And this will be 1 by 6 x1 plus y1 minus 2 z1 whole square is equal to 7, right? Now take LCM here. So LCM is 6. Take LCM 6 so into 2 into 2. So 2 times x1 plus y1 plus z1 whole square and into 3 into 3. So 3 times x1 minus y1 whole square into 1 into x1 plus y1 minus 2 times z1 whole square whole divided by 6. Let's take this LCM here. So let's put this 1 by 6 here. Right, I've just taken LCM is equal to 7. Bring this 6 to that side. So we will have 2 times. So expanding a plus b plus c whole square formula. So a square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times ca, right? And let's keep this 3 and expanding a minus b whole square formula. So a square plus b square minus 2 times ab and here you will have 1 into a plus b plus c whole square formula. So a square plus b square plus c square plus 2 times ab plus 2 times bc. So 2 times this into this will be minus 4 times y1 z1 plus 2 times ca. So you will have minus 4 times z1 x1 is equal to 42, right? So 6 into 7 is 42. So simplify this. So 2x1 square plus 2y1 square plus 2z1 square plus 4x1 y1 plus 4y1 z1 plus 4z1 x1. Multiply this 3 here. So 3x1 square plus 3y1 square minus 6x1 y1, right? Let us write here minus 6x1 y1. And here we have x1 square plus y1 square plus z1 square. Sorry, x1 square plus y1 square plus 4z1 square plus 2 times x1 y1 minus 4 times y1 z1 minus 4 times z1 x1 is equal to 42. Now when you add it up, so 2 plus 3 plus 5, so it will be 6x1 square, 6y1 square, 6z1 square. So these two will get, all three will get cancelled, right? 4 minus 6 is minus 2, minus 2 plus 2 is 0. And these two will get cancelled, these two will get cancelled, right? Because our opposite sign is equal to 42, or we divide this by 6, x1 square plus y1 square plus z1 square is equal to 7, right? It's the required locus that your x1, y1, z1 will satisfy. So all your point x1, y1, z1 will satisfy x1 square plus y1 square plus z1 square is equal to 7, right? So we need to find locus of a point such that the sum of the squares of whose distance from the plane is 7. So p1 square plus p2 square plus p3 square that has to be equal to 7. So whenever your x1, y1, z1 satisfies this equation, it will satisfy that p1 square plus p2 square plus p3 square is 7. Here we are taking r to be equal to perpendicular distance only, right? Just for understanding, I'm drawing like this, all are perpendicular distance only, right? All are perpendicular distance only. So it is three-dimensional, very hard to visualize. That's it. So we are done with this topic. The next class we'll moving on to next subtopic. So in the topic angle between the planes and the note we have discussed, we have solved 11 problems. So the next class will continue in the next subtopic, right? So go through all the problems, very easy problem only, right? So we'll see in the next class, right? So thank you. All the best.